Section 3.3, Characteristics of Polynomial Functions in Factored Form. The learning goals for today's lesson are to define the term order as it relates to polynomial functions and expressions, sketch a graph of a polynomial function based on its roots, the order of its factors and leading coefficient, and determine the equation of a polynomial function based on the graph. The order in a factored polynomial function or expression is the exponent to which the factor is raised to. So if you're given the following, f at x is equal to negative x plus 2 squared, bracket x minus 1, bracket x minus 9 over 4 cubed, we can look at the order of each of those factors. So we'll start by taking a look at the order of the first factor here. Right? So if we just take a look at this order right here, the order of that first factor is the exponent to which this factor is raised to. So we see that the order of the x plus 2 factor is 2, right? The order of the x minus 1 factor right here, well, it's raised to the exponent 1, so the order is 1, and the order of this factor over here is 3. Now, if we were to expand this factored polynomial function completely, all right, so we expand this, then multiply it by this, expand, and then multiply all these together, the highest exponent on x would be 6. And we can see that because of the following. Well, when we expand this, the highest exponent would be 2 when we expand this binomial squared. The exponent on the x would be 2. Then x squared, when we multiply into here, well, we're multiplying by x, so it would be x cubed. And then when we expand x minus 9 over 4 cubed, this would be x cubed as well. So then x cubed times x cubed, well, that's equal to x to the power of 6. So the function is to degree 6. So it is an even degree polynomial function. The other thing that you may have noticed as well is that the leading coefficient is negative. And so I'll actually put that in here just as a side note. We have a negative leading coefficient. So I have an even degree polynomial with a negative leading coefficient. That means that it's going to open down. So what I did is I then went to Desmos and I plugged this in and I graphed this out. And as we can see here, yeah, we have a function that is opening down, right? This is the function right here, and it's opening down. Yeah, it has an absolute maximum at this point right here, right? And it's even degree, right? Okay, great. So what we're going to do is we are now going to look at answer some of these questions here. So how do the x-intercepts relate to the equation of the function? Well, if we look at the function, remember, x-intercepts are values of x that cause the function to be equal to 0, right? So they're the values of x that cause y to be equal to 0. So if we look at the first factor over here, we have x plus 2, right? So the first x-intercept is, as we can see here, negative 2. So when we sub negative 2 into this first factor, we get negative 2 plus 2, well, that's 0. 0 squared is just 0 again, and then 0 times anything after that causes your function to be 0, right? It's called the zero product rule. Anything times 0 is just equal to 0. So how do the x-intercepts relate to the equation of the function? Okay. So the x-intercepts, they are the values of x that cause each factor to be 0. So we take a look at what the x-intercepts are, and I can actually just look at the equation and I can tell you what they are. One x-intercept should be -2, the other x-intercept should be 1, and the final x-intercept should be 9/4. Okay, so -2, that would cause this to be 0. There you go. 1. Okay, great. That causes that to be 0, and then therefore the entire function to be 0. And then 2.25, right, which is this over here. Okay, 9/4, 2.25. So those are the values of x that cause each factor to be 0 and therefore the function to be 0. So we'll write them over here. X is equal to -2, 1, and 9/4. What is the behavior around x is equal to -2? So if we take a look at this function around this 0, how does the function behave? Well, if we were just to look at the behavior around this function and we were to ignore the rest of the function, we might say, okay, that looks like it's a quadratic, right? That looks like a parabola around x is equal to -2. So around x is equal to -2, it looks like a parabola. And that makes sense because if we look at the factor is order 2, right? So x plus 2 is raised to the power of 2, and anything raised to the power of 2 is a quadratic, right? A function raised to the power of 2, or x raised to the power of 2 is a quadratic, right? So the behavior around x is equal to -2 is going to behave like a parabola, and that's because we had x plus 2 raised to the power of 2. Without looking at the graph, let's take a look at this factor. Around x is equal to 1. Okay, well, the factor there was x minus 1. It was raised to the power of 1. And something raised to the power of 1 is going to be like a line, right? It's going to be linear. X raised to the power of 1, so y is equal to x, that's, linear. And so let's take a look around 1 and see if it does in fact behave like a line around that x-intercept. We can see, yeah, it does kind of behave like a line because it just passes through that one point, right? In fact, we could draw potentially a line that more or less fits that curve going through that x-intercept. And then if we look around this right here, well, we can see that it is raised to the power of 3. Right? This factor is raised to the power of 3. And so it should behave like a cubic around 9/4. And you may recall, and I'm just going to sort of sketch this out for you, but cubics behave like this around their x-intercepts. They come down and they make this like S turn around their cubic, and maybe that wasn't necessarily the best way to draw it, but they kind of have this like S shape around their x-intercepts. And let's take a look if it makes that S shape. Well, yeah, it kind of does, right? It comes down and then curves down again, right? This is not considered a turning point because the slope doesn't change, right? The slope goes from being negative and it's still negative, so it's decreasing and then continues to decrease. So it's not a turning point, but it definitely has that cubic or S shape to it. Okay. And then what is 0, -45.563? Well, that's the y-intercept. Okay. And we can find the y-intercept simply by setting x equal to 0. Finally, it says, how could we know if it was opening down with the same end behavior? Well, it had a negative leading coefficient, right? So it had a negative leading coefficient. And in the previous lesson, we found that anything with a negative leading coefficient is going to open down if it is an even function. Negative leading coefficient opening down since it is an even degree function. Okay, let's move on to some other examples here. All right, it says exploring the behavior of factored polynomial functions. Graph the following functions using a graphing app such as Desmos. For each, determine the zeros and describe the behavior near each zero. Compare the shape of the graph near the zero to the order of the corresponding factor. So what I would like to do is I kind of want to actually, instead of using Desmos to do this, I'm just going to zoom in on these functions and using the concepts that we learned, I'm just going to sketch the graph for us. Okay, so give me a second and I will just zoom in on this. Okay, so the first function that we're looking at is y is equal to x minus 2, x plus 1. So if we take a look at this, the zeros here, or the x-intercepts, are as follows. X is equal to 2, and that came from the factor x minus 2, which was raised to the power of 1, right? The exponent on that factor is 1. So therefore, it's going to behave linearly through that x-intercept. The other x-intercept is x is equal to negative 1. That came from the factor x plus 1. Again, it should behave linearly through that factor. And if we look at the function there, we see that it has a positive leading coefficient. So it has a positive leading coefficient. Let me just write that. Positive leading coefficient. And so that means that it is going to open up. Okay, so what I'll do is I will just plot these right here. So I've got an x-intercept here, and I have an x-intercept over here at negative 1. Okay, and then effectively, if I want to find, I can see that this is going to be a quadratic, right? And it's going to be opening up. If I wanted to find the vertex of that, remember that the vertex is going to be halfway between here and here, right? So the vertex will be halfway between these 2 points, because it's always, remember, the vertex is in the middle of the parabola. So this right here is a total of 3 units. So halfway in between is right here at 0.5. So to find the vertex, I'm going to set x equal to 0.5 because that is halfway between the zeros. Right? Again, that parabola has symmetry, right? So the vertex is located right in the middle of the parabola. Okay, I'm just going to input that and see what I come up with rather for the vertex. Okay, so when I inputted 0.5 into the equation right here, the y value that came out was negative 2.25, which is right here. And there, now I have my vertex, and I can open up like this. And as we see, it behaves linearly through that portion of the or through those x-intercepts. All right, let's scroll down a little bit and let's take a look at the next one. Okay, so this one over here, we can see that the degree here is going to be, well, x minus 2 squared, and then we have x multiplied by x again, so the degree is going to be 3. So this is going to be a cubic and it has a positive leading coefficient. So it's degree 3 positive leading coefficient. So what that tells me is that it is going to go from the third quadrant to the first quadrant because it has a positive leading coefficient and it's degree 3. But let's take a look at the zeros. The first zero is x is equal to 2. And the description of that zero, well, because that factor right there, it's x minus 2 squared, it's going to behave like a quadratic, right, or a parabola through that zero. So we're going to have basically a vertex at x is equal to 2. Right? We're going to have a vertex there at that zero. For x is equal to -1, that factor is going to be a linear factor, excuse me. That factor is going to be a linear factor, which means that it's just going to pass through x is equal to -1. So I'm going to plot my zeros here. So I've got x is equal to 2 and x is equal to -1. And recall that it basically has to go from the third quadrant to the first quadrant, right? Because it is an odd degree polynomial with a positive leading coefficient. It has to pass through this linearly, okay? And the other thing that I can do is I can find the y-intercept here. And I can find the y-intercept by setting x is equal to 0. So I'll get one more point here. So 0 minus 2, well, that's just -2, and -2 squared is 4. And then 0 plus 1 is just 1, so 4 times 1 is just 4. So my y-intercept is right here. So now I have enough information to draw a relatively accurate graph here. So it's coming from the third quadrant. It's going to go through this point right here, then to the y-intercept, and then it's going to curve back down, and it's going to behave like a quadratic right at this point. So it's just going to touch x is equal to 2, and then it's going to come back up like that. Okay? At this point, you don't have the tools required to know where the turning point is going to be. So I just ask that you approximate where the turning point is going to be. But you certainly do not need to know where exactly that is. You just need to know that it passes through, comes down, and goes back up, right? And so we just found that that's the y-intercept right there. Okay, good. Degree 3, cubic, positive leading coefficient, going from the third quadrant to the first quadrant. It behaves like a parabola around x is equal to 2, and it behaves like a line around x is equal to -1. All right, let's take a look now at question or example 3. If we look at example 3, here we have y is equal to x, x plus 3, x minus 5. Again, if we were to expand that out, the degree of this polynomial, and I'll just, I'll put it over here, the degree of this polynomial is going to be 3, right, when we expand all these factors. So we have an odd degree polynomial, and we have a positive leading coefficient. So this means that with a positive leading coefficient and degree 3, this means that we're going to go from the third quadrant to the first quadrant. When I look at my zeros here, I have 3 zeros. I have x is equal to 0, right? That would cause this function to be equal to 0, and x is raised to the power of 1. So if x is raised to the power of 1, that means it's going to behave linearly through x is equal to 1. Or sorry, x is equal to 0. It's going to behave like a line. I've got x is equal to -3. That means because I've got x plus 3, again, it's going to behave linearly through that 0. And then x is equal to 5. That comes from x minus 5. Again, that's raised to the power of 1, so it's going to behave linearly through that. And the last thing that I can do is I can set y equal to 0, right, to find the set y is equal to 0 to find the y-intercept. Set x is equal to 0 to find the y-intercept, and then I would have y is equal to 0, 0 plus 3, 0 minus 5, so y is also equal to 0. So my y-intercept is 0, 0. So, okay, I can plot my y-intercept, and I can plot the other 0 as well. One of the zeros was x is equal to 0, x is equal to -3, and x is equal to 5. And I have to know that I've got to go from the third quadrant here to the first quadrant because it is degree 3 with a positive leading coefficient. And so now I just kind of sketch out my graph here. Right, so I've got it coming up from the third quadrant. It's got to pass through that linearly. Then it's got to pass through this linearly. And it's got to pass through this linearly. And I end up with my quadratic there. Probably not your best sketch, but you know, this will do in a pinch. Okay, I think this meets all the characteristics that we need. It goes through the zeros that we identified based on the factors. We have a 0 at -3, a 0 at 0, and a 0 at x is equal to 5. It's going from the third quadrant to the first quadrant, and we've got the correct y-intercept. All right, moving on to this one right here. Again, first thing that you're going to do is you're going to take a look at this. What would the degree be if it was all expanded? Well, if it was all expanded, the degree would be 4, which means it's an even degree function. So that tells me it's got either going to open up or it's going to open down. Then I take a look at the leading coefficient. The leading coefficient is positive, so degree 4, positive leading coefficient, which means it's going to open up. All right, now I'm going to look at my zeros here. And my zeros are at x is equal to 0. And when x is equal to 0, that's going to behave like a cubic, right? Because it was x cubed, right? So it's going to behave, make that S shape around x is equal to 0. And at x is equal to 6, we had this factor, right? And that's raised to the power of 1. So it's going to behave linearly through x is equal to 6. Now I'm going to set my set x is equal to 0. Okay, set x equal to 0 to find my y-intercept. Y is equal to 0 cubed, 0 minus 6, and y is equal to 0. So my y-intercept is at 0, 0. Okay, so I've got an even degree function of 4. It has a 0 at x is equal to 0 and a 0 at x is equal to 6. So that means it's going to behave like a line through here and with an S shape here, and it has to open up. Okay, so what I'll do is I will start over here and I'll come down, and then I'll initiate my S right here. Okay, and then it's going to come down again. And it has to go up through x is equal to 6 and come back up. Okay, again, I have no idea how far down it's going to go. That's not something that you have the tools available to you at this point to learn, but you can just sort of sketch that out right there. You kind of want to draw this relatively between the two zeros. All right, so we have our function here. It's degree 4, opening up, going through the correct number of zeros, and behaving correctly through those zeros. Cubic, so S shape through that 0, and linearly through that 0. All right, the final example here that we're going to do is this one, which is x cubed, x minus 6, x plus 6. Again, we expand that all out, and we would have degree 5. Okay. And we have a positive leading coefficient, so we know that it's going from the third quadrant to the first quadrant. Positive leading. My zeros are, excuse me, x is equal to 0, and that's because I've got a cubic. So cubic behavior around x is equal to 0, and then I've got x is equal to 6. So x minus 6, it's going to behave linearly through that 0, and x is equal to -6. So it's also going to behave linearly through that one as well, because these are both raised to the power of 1. Okay, the other thing that I need to do is I need to plot my y-intercept. So I need to set x equal to 0. And if I do that by setting x is equal to 0, I've got 0, 0 minus 6, 0 plus 6, so y would equal to 0. So my y-intercept is also at 0, 0. Okay, let's plot these zeros here and the y-intercept, which happens to be the same right there, 6 and negative 6. It's degree 5 and it has a positive leading coefficient, so that means that it's going to go from the third quadrant to the first quadrant. And it's going to behave cubically through here, but linearly through here and linearly through here. So if it's going to behave linearly through here, I'm going to start in the third quadrant and I'm going to come up like this. And then I'm going to curve it and then start initiating my S. And then come back down and then proceed through here linearly as well. It looks like I kind of missed the 0, but I think you get the idea. Okay, so this sufficiently graphs it because I have all my zeros in place. I have my y-intercept in place. I have the correct behavior, which is to say that it goes from the third quadrant to the first quadrant as a result of the positive leading coefficient. And it's degree 5, right? Which means that if it's an odd degree, there's going to be no absolute maximum or minimums, right? There's just going to be local maximum and minimums, right? There's your local maximum somewhere in that area. And those are your local minimum somewhere in that area. Again, you do not have the tools to know how to find the exact locations of those maximum and minimum at this point. One thing I would like to just add to this note is the following, which is a definition of families of functions. Okay, so because this comes up in the notes, so families of functions is as follows. Families of functions, they have the same degree, right? Same overall degree. So for example, they could be cubics or quartics or quintics, right? So they have the same degree and they also have the same x-intercepts. All right. So here is an example of two functions that belong to the same family of functions. So say I had y is equal to x minus 2, x plus 3, and x minus 3. Okay, as you can see, that's a, oh, sorry, I don't think you guys can see that. Give me a quick second here. Okay, so we see that we can see that they have the same degree, same x-intercepts. Here's your cubic function. So that's one function, and this function right here, y is equal to negative 1/2 x minus 2, x plus 3, x minus 3. These two would be part of the same family because they have the same x-intercepts, which is to say 2, negative 3, positive 3. They have the same degree because they're both cubics. The only difference here is that they have a different leading coefficient. This one is positive 1 and this one is negative 1/2. Just another quick example there would be like y is equal to, and if I wanted to belabor the point or make it a little bit more obvious, right, I could say like 500, right? X minus 2, x plus 3, x minus 3. Okay, again, those are actually, those would be the same as well. Okay, all of these would be part of the same family. They have the same degree and same x-intercepts. Okay, looking at example 1, says sketch a graph of the function y is equal to 1/2 x plus 3, x minus 2 using the zeros, y-intercepts, and end behavior. So the first thing that I'm going to do is I'm going to look at what the degree is. And I see that the degree for this will be degree 3 when I go to overall expand this, right? So it's going to be an odd degree function. Then what I'm going to do is I'm going to look at the leading coefficient. I see it's 1/2, so it's a positive leading coefficient. And if it's a positive leading coefficient, that means it goes from the third quadrant to the first quadrant. And then I'll take a look at the zeros. Well, I have a 0 at x is equal to -3. And at x is equal to -3, I can see that factor is raised to the exponent 1 right here. So it's going to behave linearly through that factor. And then I also have x is equal to 2. And I can see that around that 0, that factor is raised to the power of 2. So it's going to behave like a parabola or a quadratic through x is equal to 2. Finally, I need to find my y-intercept. So my y-intercept is as follows. I have to set x is equal to 0 and then solve for y. So y would therefore be equal to, y is equal to 1/2, 0 plus 3, 0 minus 2 squared. So the -2 squared is 4, 4 times 3 is 12, right? 12 divided by 2 is 6, so y is equal to 6. So my y-intercept is going to be 0, positive 6. So now what I'll do is I'll just kind of plot these, and as you can see I don't have a grid, so I'm just going to kind of do like a, an estimation here. So I've got x is equal to -3, and I'll just write that in right there. That's equal to -3, 0. And then I've got my y-intercept, which is 0, 6. So I'll put that up here, 0, 6. And then what I'll do is I'll also find my third 0, which was x is equal to 2. And so I'll approximate that is right here. That's equal to 2, 0. I know that I have to go from the third quadrant to the first quadrant because it has a positive leading coefficient. So what I'm going to do is I'm going to go here, okay, through this, and then behave like a quadratic through 2. So linearly through -3. Okay. I don't know where my turning point is, but I know that I have to go through 0, 6. And then I know I have to behave like a quadratic around here. So I have to behave like a parabola around here. And there's my function. And I'm just going to label it right here. Y is equal to 1/2 x plus 3 x minus 2 squared. Okay. Again, a little bit of a shaky curve there, but that's more a result of the technology that I'm using than anything. Okay, example 2. A quadratic has roots 3 and -5. Determine the equation of the function if f at 2 is equal to 10. So if a quadratic has roots 3 and -5, I can use a factored form for this. And what I can say is f at x is equal to some stretch factor or some leading coefficient a, and then x minus 3, x plus 5, right? Because 3 and 5 will cause this equation to be equal to 0. Now I have to determine what that stretch factor is, right? Or what that what that leading coefficient is. I don't know if it's positive or negative at this point. But what I do have is that f at 2 is equal to 10, right? So if f at the x value of 2 is equal to 10, then 10 is equal to a, 2 minus 3, 2 plus 5, right? And so what I would have there is 2 minus 3 is -1, 2 plus 5 is 7. So what I would end up with is 10 is equal to -7a, and therefore a is equal to -10/7. And so my final function, the equation of the function, would be f at x is equal to -10/7 x minus 3 x plus 5. Okay, so that's a pretty standard question that often gets asked in this unit, right? Gives you the roots, gives you a value of the function, and then you have to find the leading coefficient. And in this case, the leading coefficient is -10/7, so this quadratic would definitely open down. Find the equation of a cubic function with roots -2 to the order 1 and 3 to the order 2, and it has a y-intercept of 20. So a little bit more complicated. If it's a cubic function, so let's go f at x. Again, it's got some sort of leading coefficient, a. One of the roots is -2. So x plus 2, that would cause this to be equal to 0. And it's order 1. So I could put a 1 up there, but I don't have to. I'll leave it for now. And then 3, so x minus 3. But this one is to the order 2. Okay? And I can see that if I were to expand all of this, that would be a cubic, right? So what I'll do is I'll just get rid of this right now. And then it's the same idea here. The x-intercept is equal to 20. So that means if the y-intercept is equal to 20. So that means that when x is 0, the y value is 20, right? So if I know that f at 0 is equal to 20, then I could say, therefore, 20 is equal to a, and 0 plus 2, 0 minus 3 squared. Okay, and then 20 is equal to a, 2, -3 squared. Okay, so the -3 squared is 9, 9 times 2 is 18, and then I would have 20 over 18 is equal to a, and I would need to reduce that because that can be reduced even further, and I would have 10 over 9 is equal to a. Therefore, 10 over 9 is equal to a, and so the equation of the cubic function would be f at x is equal to 10 over 9, x plus 2, x minus 3 squared. Two more quick examples here. Determine the equation of the following function. Well, I can see right here that it's opening down, right? So it opens down, which means that it's going to be an even degree function, right? And it's going to have a negative leading coefficient. All right, and then I take a look at the function right here, and I look at the zeros around here. Well, I can see it kind of behaves like a quadratic right here. It's got like that parabola shape to it where it just touches and then it comes back down. Okay, and then over here at 0, 0, looks like it kind of behaves like a line, like a very low sloped line, right? So I've got a linear behavior through here, and I've got linear behavior through here. So my function there would be f at x is equal to a, some leading coefficient. I know that my a value should be negative, right, because it's opening down. Quadratic behavior around x is equal to 1. So at this 0, x plus 1, I've got quadratic behavior or parabolic behavior, so I've got to do x plus 1 squared. Then I have another 0 at x is equal to 0, and that's linear, so I'll just write x, right? Because if x is equal to 0, the rest of this would be equal to 0. And then over here at x is equal to 4, that's one of my zeros, so x minus 4, right? Because 4 minus 4 would cause this to be 0. And it behaves linearly through that, so that's to the power of 1. All right, this all makes sense because if I were to expand this, I would have an even degree. It would be to the power of 4, x to the power of 4. And I need to find my leading coefficient right here, and I know it should be negative. What I can do is I have a point right here, 3, 6. So that means that 6, the y value or the f at x value, is equal to a 3 plus 1 squared times 3 minus 4. All right. And so when I go to evaluate this right here, I get 6 is equal to, looks like I get a negative 48 a, right? So 4 squared is 16. 16 times 3 is 48, and 48 times -1 is -48. So a is equal to 6, or -6 over 48. Since 6 is a factor of 48, this is just equal to -1 over 8 is equal to a. -1 over 8 is equal to a, so therefore the value of the function, or rather the equation of the function, is -1 over 8 x plus 1 squared times x minus 4, and that's fine. Okay. Alternatively, you could rewrite it like this: -1 over 8 x minus 4 x plus 1 squared, but the above, this right here, is fine as well. Okay, last question, and this should be, we'll do this one relatively quickly. If I take a look at this one right here, I can see that it is degree 4, so it's going to be an even degree function, which means it's going to open up or down. It has a positive leading coefficient, so that means it's going to open up. But I need to find the zeros for this function, and I need to find my y-intercept. So I can factor this right here by doing x, and then actually, in fact, I could do x cubed, right? And then I would have x plus 2. And that tells me that I have two zeros. I have a 0 at x is equal to 0, and it's going to behave cubically through that. So this is one of my zeros. And then x is equal to -2. And at x is equal to -2, I have linear behavior, like this. Okay. So I've got to have that S shape through x is equal to 0. I've got to have linear behavior through x is equal to -2, and it has to open up. And you would see also that your y-intercept is also equal to 0, 0, because if you set this function equal to 0, then you end up with your x value, or sorry, if you set x is equal to 0 rather, you end up with a y value of 0. So that's also your y-intercept. So at x is equal to -2, we've got some linear behavior, and remember it's going to be opening up, so I've got to go here linearly through that, and then I have to behave cubically through this right here, and like that. Okay, and I'm just going to make a small adjustment here. Okay, let's just pretend that it went through right there. Okay, and then I'll put right there -2, 0. Sorry. Let's write that a bit better. -2, 0, 0, 0, and this is the graph of that function. Okay, apologies for the length of this lesson. There's a lot of material covered here. Here's the homework. There's quite a lot of it. I would suggest maybe when you have multiple parts to a question, just do maybe the odd or even, and then save the other ones that you don't do for just before the test. Okay, thanks for your patience. I appreciate you watching, and best of luck with the homework.